Hi, I'm Steren Giannini. Welcome to Cloud Run What's New. So, a year ago, we launched publicly Cloud Run. In this session, I'm going to go over the few improvements that we've released since then. This session will be structured in three dimensions. We'll see how Cloud Run is now even more enterprise ready, how it is more developer friendly, and how it gives you more flexibility. But first, I want to recap what is Cloud Run. So Cloud Run allows you to run containers on a fully managed environment. We can call that serverless. Its main characteristics are that it auto-scales, there is no infrastructure to manage, and it allows you to go fast. It makes you productive. So as I said, you can deploy containers in seconds. And thanks to that, you can use any languages, any library you want because of containers. We spent a lot of time delivering an enhanced developer experience so that we make you productive when using Cloud Run. A few nice things is that when you deploy to Cloud Run, you get out of the box an automatic HTTPS endpoint for your service, and you can attach your own custom domain very easily. Cloud Run is portable. First, because it accepts the container standard as an input, but also because it is based on Knative, an open source project that allows you to run serverless workloads anywhere. And Cloud Run is also available for Anthos, allowing you to run the same Cloud Run workloads in your own cluster, be it on Google Cloud, on other clouds, or on-prem. And finally, Cloud Run is pay per use. You literally only pay for when your containers are processing requests, rounded up to 100 milliseconds. So with that, let's dive in. Let's see how Cloud Run is now even more enterprise ready. So first, when we launched a year ago, we launched to beta. And today we are generally available. Of course, that comes with all of the goodness of a generally available product of GCP in terms of support and in terms of service level agreement. Cloud Run has 99.95 availability SLA. Then we've been very hard at work to turn on Cloud Run in many different regions all over the world. So what you see on that map are the green dots are where Cloud Run is available today, and the blue dots is where we plan to open Cloud Run by the end of the year. So as you've seen, we now cover all continents, and we are hard at work to turning up even more regions very soon. Then one of the key feature that we added that was requested by many of you was the ability to access your resources that are in your VPC, in your virtual private cloud. So for example, thanks to serverless VPC connectors, Cloud Run can now connect to Cloud Memory Store Redis or Memcache, or simply connect to a private IP of a compute engine VM, for example. Next, we when we release Cloud Run, you could anytime you were deploying a new revision of a Cloud Run service, this revision was starting to serve traffic as fast as possible to 100%. Well, we all know that's not really how we should deliver software, right? So what we added is the capability to control the rollout of your revisions or even to roll back to a previous revision. So let's see an example of what we call a blue-green deployment. So let's assume we are in a revision that we will call blue, and we want to deploy to something called green. So the first step is to, of course, deploy that new revision. So let's assume I want to deploy a new image of my container. So I would use the regular command you would know, except that this time I'm going to say do not serve traffic. And I'm going to give it a tag, green, for this example. Of course, I'm showing you this with the command line, but you can do exactly the same from the Cloud Console. Once I've done that, this revision that was created is not going to serve traffic, but I, as a developer, or my team, can give it a try, can invoke it under a very specific URL that contains the tag that we just added. So once I validated that this new revision is ready to go, is behaving correctly, then it's time to send traffic to it gradually. So I will start small. I will start by sending 1% of the traffic to that new revision. So in that case, I'm using the update traffic command, and I'm going to say send 1% to the tag green. And the system will know that the tag green is attached to a specific revision and that 1% of the incoming external traffic should go to that new revision. From my end, what I should do now is take a look at my monitoring dashboard, my logs, filter by this revision name, and double check that everything is fine. Once I confirm that everything is good to continue, then it's time to send more traffic to that revision. So I'm going to send 10%, wait a little bit, double check everything is fine, send 50%, wait a little bit, check everything is fine, and finally send 100% of the incoming traffic to that new revision. By the way, at Google, we mostly do our gradual rollouts over 4 days, making sure that everything is healthy between each steps. Once I've done that, I'm good to go. This new revision is serving all of the incoming traffic, and I consider this which is the new current revision. If at any point in time during the rollout or at any point in time, I can roll back to a previous revision. To do so, it's one click in the user interface or one command with gcloud, which is an update. I update the traffic, but this time to a specific revision name, and I send 100% of the traffic to it, which means I'm going to roll back to that revision. So hopefully that can help you more safely release your container and your software by giving you more control and allow you to traffic splits between revisions. All right. Then we added support for Google Cloud Artifact Registry. So Artifact Registry is the evolution of Google Cloud Container Registry. And the benefits of it is that you can have container registries in very specific regions, in the regions you want. So that's even better for data locality so that you can store your containers in wherever you want. You can even use your own encryption keys to encrypt those containers in the registry. Cloud Artifact Registry has a free tier, which is always good, and you can have per repository access control using Cloud IAM. So in the example on the right, what I'm doing is that I'm deploying to Cloud Run from Artifact Registry, where my registry is actually from Europe North 1, a very specific region in Europe. Okay, next, in the enterprise ready category, we added support for Google Cloud load balancing. So what that helps you do, for example, is that if you deploy the same Cloud Run service in 3 different regions, you can add on top of them Google Cloud Load Balancer and expose a global endpoint that will route requests to the closest region in order to reduce latency, but also to be resilient to regional outages in case something goes bad in a Google Cloud region. So let's see an example. Here, somebody from San Francisco connects to my global endpoint. Well, Google Cloud Load Balancer will route that request to my Cloud Run service, which is in the US. But now, if somebody from Paris connects to that same global endpoint, then Google Cloud Load Balancer will send the request to Europe West 1. So you see how you can build global services with increased availability and performances on top of multiple Cloud Run services. But that's not all. Google Cloud Load Balancer allows you to use Cloud CDN. So now, by using Google Cloud Load Balancer and Cloud CDN on top of Cloud Run, you can, for example, reduce the load on your Cloud Run service or increase performance of your service. So let's see this example. The very first request comes in. This one, is not cached because nobody has seen it before. This one will reach the Cloud Run service. Cloud Run can respond with a special response header, which is cache control, and saying, I want you to cache this request for 300 seconds. Good. Next time a client asks the same, Cloud CDN will be able to return the request without even it needing to reach your Cloud Run service. So you see how by caching some requests, you can drastically reduce the load on your service and performance. So that's not all. Google Cloud Load Balancer integration gives us even more. Identity-aware proxy is something that allows you to add basically a logging screen on top of your Cloud Run service. And this logging screen can enable you to grant access to only certain users inside your organization. For example, your employee for an internal application. So once again, identity-aware proxy via Google Cloud Load Balancing on top of Cloud Run. And very similarly, you can use Cloud Armor thanks to Google Cloud Load Balancing. So Cloud Armor is a web application firewall. It will help you, in case of a denial of service attack, and it will help you, accept only some IPs from certain IP ranges or geographies. So in this example on the right, I am only accepting IPs from a range, and the others get rejected. So the rejected ones don't even reach my Cloud Run service. This is all handled by Cloud Armor via Google Cloud Load Balancer. So hopefully we are convincing you how Cloud Run is even more than before enterprise ready with all of those very important features that you've been asking us to deliver. Now let's see how Cloud Run is even more developer friendly. So first, we've heard your feedback, and thank you for sharing that you like Cloud Run. We measured via some Cloud Console surveys that most of you are very satisfied with Cloud Run, and so we are pleased to hear that. And this is one of the highest satisfaction score that we've seen for Google Cloud. So we are very proud of this. But we haven't stopped there. We are keeping delivering many developer-focused features to make you even more productive. And one of them is the ability to deploy from a YAML file. So if you want to store the configuration of your Cloud Run services in your version control system, in config files, well, you can. And actually, because Cloud Run implements the Knative Serving API, this file is exactly a Knative Serving resource descriptor. So this is what, with that, you can achieve what some people call GitOps, which is you use Git as your source of truth when it comes to your resource configuration. So we've added a new command to gcloud called gcloud run services replace, and that takes a YAML file of your service. Next, we've worked with the Cloud Code team to bring Cloud Run integration inside the Cloud Code IDE plugins for IntelliJ and Visual Studio Code. So this plugin will help you bootstrap new Cloud Run apps with sample apps. It will help you manage your services and your revisions, see their properties. It will help you build your source code into containers and deploy them to Cloud Run. And my favorite, it will help you run your Cloud Run services locally inside a containerized environment that looks a lot what you would have if you deploy it to Cloud Run. Next, Google Cloud has released Google Cloud buildpacks. So buildpacks are basically recipes to create containers in a set of very popular languages. In our case, the Google Cloud buildpacks support Go, Node.js, Python, Java, and .NET. Thanks to buildpacks, you don't need to worry about writing Docker files anymore. If you see the example on the right, my source code doesn't contain any Docker file, and I'm able to build it with Cloud Build using the --pack command into a container that I can then deploy to Cloud Run. Buildpacks are, those buildpacks are open source, and buildpacks are a CNCF open standard that are used by many vendors. So we are very proud to have them today to help you build containers. Next is that when you deploy to Cloud Run and when you build your container from a Git repository, we now capture the context of this container and display that right inside the user interface. So if you see on that slide, you see how, in addition to the container image URL, we give you a link to the build that was used to create that container, as well as a link to the GitHub repository at this specific commit for you to troubleshoot in case something is wrong with that particular container. And on a similar fashion, we are also helping you embrace the best practices of continuous deployment. So right now, from the Cloud Run user interface, you can, in a few clicks, configure a continuous deployment pipeline for your Cloud Run service. So let's take a look. Right now, I'm creating a new service, and I'm gonna, instead of picking a specific container that I already built, I'm gonna select a Git repository. So when I click this, it asks me to authenticate with GitHub if GitHub is where your Git repositories are. Then I can select one of my repositories. I validate the build configuration, giving it a location of my Docker file and my branch. I hit save, and then Cloud Run will create the Cloud Run service as well as create a Cloud Build trigger that will automatically watch this repository for new commits. And when they are pushed to this repository, will automatically build and deploy to Cloud Run. So in that case, we trigger the first build, and your service is now serving with the code that was in your Git repository. Over time, we even show you the history of the builds right inside the Cloud Run user interface for convenience. But that's not all what we've delivered for developers. I'm very excited to say that we are launching new ways to trigger your Cloud Run services via events. So basically, you can now trigger Cloud Run services when events are emitted from other Google Cloud resources. So this is all based on Cloud audit logs. So you might know that GCP resources, anytime they are changed or they emit audit logs. So very easily, what you can do now is you can trigger your Cloud Run service anytime one of your GCP resource is mutated. And the events that you receive to your Cloud Run service are delivered in an open standard again, the Cloud Event Open Standard, which is a CNCF project. So I'm also very excited to say that we are launching Cloud Workflows. So Cloud Workflows allow you to orchestrate your serverless tasks with a rich and declarative programming model. For example, you want to process events with multiple Cloud Run services. You can chain API calls. You can automate infrastructure management. You can implement retries policies very easily thanks to Cloud Workflows. So in this example on the right, what I'm doing very simply is every day I want to stop all of my developer machines. So to do that, every day at 6 p.m., one Cloud Run service returns me a list of all of the dev VMs. Another one extracts their statuses. And for each VM, I extract the status. If it is running, I stop it, and then I email the owner of this VM to make sure that tomorrow they don't forget to stop them. So you see how you can build complex workflows by bringing together very simple serverless pieces. So that's it. That's how we have made Cloud Run even more developer friendly over the last month. And we are not stopping there, of course. Now let's see how we've heard your feedback, and we've been removing some of the limits that Cloud Run had at the beginning by giving you more flexibility. So first, we heard you want more RAM, you want more CPUs. So you can now go up to 4 gigabytes of memory and 4 vCPUs. On a very similar fashion, in the past, you were limited to 15 minutes of request processing time. We are now extending that to an hour. So you can process things up to 1 hour on Cloud Run. Next, once again, we are delivering something that a lot of you have been asking for. Today, as I mentioned, Cloud Run auto-scales, and notably scales down to 0. So that's great, but that means that when there is no traffic and suddenly there is traffic that comes in, you have what we call a cold start, which is the time it takes to go from 0 container instances to 1 container instances or more. And this usually depends a lot on what your container is doing at startup time. With min instances, you can say, hey, I want a minimum of, for example, 2 instances, always 1 at any point in time. And when that's the case, Cloudrun will make sure that your number of instances never goes below the number you specified. So that's great for improving performances, notably when it scales down to 0. But the good news is that those instances, when they are not in use, actually are cheaper than active instances. Another thing we've added to help you better handle the auto-scaling of Cloudrun is that we are now sending a signal before the instance is shutting down. So that gives you the time, for example, to close any open database connection or to send any data that you might not have sent and kept in memory. By sending this seek term signal, you have up to 10 seconds of processing time when you can do something before the instance is shut down. We've also heard you. We added support for gRPC. So now, out of the box, your Cloudrun service can expose a gRPC server. That, nothing to configure, just your code has to start a gRPC server that listens on the same port as the one we are sending regular HTTP requests. So gRPC on a serverless infrastructure, yes, that's possible with Cloudrun. And lastly, we've also heard your feedback. We added support for server-side streaming. So what that means is that you can now stream your responses back to the client. You are not limited anymore by the response size of 32 megabytes, and the responses are not buffered anymore. That allows you to stream HTTP and gRPC responses. In the example on the right, what I'm doing is my small web server is actually serving a video file to the client, and I'm using this special header transfer encoding chunked. That means that the client will be downloading the stream of the bytes of this video. So hopefully this is removing some of the limits that were initially part of Cloudrun, and don't worry, we are not stopping here. We are keeping removing those existing limits. So hopefully with this talk, I convince you how Cloudrun is now even more than ever enterprise ready and even more than ever developer friendly, and by removing some of its original limits gives you more flexibility. We've been very hard at work to deliver all of these features that last year, and we are of course not going to stop here. I want to thank you for attending this session, and we can't wait to see the great things you will build with Cloudrun.